So in this video, we're going to talk about how you can use linear equations to represent real-life situations. Real-life situations that can be represented by a linear equation in the form y equals mx plus b will have a specific starting value and a rate of change. So whenever you're reading a real-life situation, if it has a very specific starting value and then it's describing a constant rate of change, you know that you can use a function in the form y equals mx plus b to represent that situation. So the way you'll plug it into the equation is the starting value will represent b, which remember is the slope of the equation, and the rate of change will represent m in the equation. Okay, so we just go ahead and plug it into y equals mx plus b. So let's look at an example. How can we formulate a function to represent Sarah's overall spending y at an amusement park where she pays $24 for admission and $3 for each ride, assuming she doesn't purchase any food or drinks during her visit? Okay, so let's think about it. So do we have a specific starting value? Yeah, if you look at it, $24 is a specific starting value because even if she doesn't ride any of the rides, she still has to pay $24. And then there's $3 per ride, right? So remember that total is like going to fluctuate depending on how many rides she takes. So the $3 is actually telling us the rate of change. So we have a specific starting value and a rate of change, so we can go ahead and plug into y equals mx plus b. So when we plug this in, we get y equals, and then the rate is going to be 3, and then times x, and then remember our starting value is going to be b, so that's 24. So y equals 3x plus 24 is the correct answer, which is our third answer choice. So now let's try this example. Which of the given scenarios can be represented by the following equation? So we have a linear equation, 2x plus 1 equals 25. So if you think about it, it kind of is in y equals mx plus b form, right? Instead of y, we have 25. Our mx is kind of like 2x, and then we have plus b, which is 1. So we're going to look for a scenario that has a rate of change of 2, and it has a starting value of 1. Okay, so that's going to be the idea here as we go through these answer choices. So in the first one, it says each hamburger costs $1 and fries cost $2. Sally has $25 to spend. Well, you think about it, the cost of a hamburger and a cost of fries, like that's telling us kind of like two rates of change, right? This is kind of like if we had 1x plus 2y equals 25. So that's like two rates of change. So that doesn't really fulfill what we were looking for, right? We want 1 to be our starting value and 2 to be the rate of change. In answer choice B, it says each player starts with 1 point and gets 2 points for each correct answer. The first person to get to 25 wins. Okay, so starts with 1 point, so that looks good. 2 points per correct answer, right? So that could be a 2x, that's a rate of change. And then we want that to get to 25. So this is already kind of looking like our right answer, but let's go ahead and check everything else just to be sure. Here it says completing each task on a to-do list takes 25 minutes. This will take Barbara 2 hours and 1 minute. So the completing each task takes 25 minutes. This is actually going to be our rate of change here, right? So that's actually not even correct in what we're looking for because we're looking for something with a rate of change of 2. Here it says D can run 2 miles per hour and walk 1 minute for a total of 25 minutes. Once again, this is giving us two rates of change, and actually this 2 miles per hour would need to even be converted to minutes because everything else is in minutes, right? We'd have to multiply this, so like 1 hour is 60 minutes. So this would be 1 mile for 30 minutes. So this would look something like 1 over 30x plus 1y equals a total of 25 minutes. So this isn't the correct answer either. Okay, so that means that this second answer choice right here is what matches the function that we were looking for.